Thanks for joining me for another episode. Many of the application vulnerabilities that we see today arise during the design and development phase. In this episode, we'll cover secure coding practices, we'll look at some best practices, we'll talk about strategies for managing your code securely, and we'll explore a simple file upload web application written in Node.js and explore some of the vulnerabilities that can arise during coding. And we'll also fix these vulnerabilities to give you an understanding of how these things work. Stay tuned, and I'll be right back. Welcome back, and let's dive right into the topic. So, we're covering secure coding today. We're looking at the essential practices for developing safe applications. We're trying to understand what it means to prevent common vulnerabilities through secure coding practices. And then the primary goal here is to equip you with knowledge that you can incorporate in your development lifecycle to prevent vulnerabilities that arise from poorly coding your applications. So, what is secure coding? Secure coding is the practice of writing code for systems, applications, or your APIs and services that ensures that the security and the integrity of those applications remains the same. Ideally, that means preventing vulnerabilities that arise because of poor coding practices. So, what are the benefits? Well, it prevents vulnerabilities, identifying and mitigating potential security risk early in the development process, prevents vulnerabilities that arise, such as SQL injections, cross-site scripting, and buffer overflows. As I mentioned, during the development lifecycle, implementing secure coding practices is essential in terms of your secure development lifecycle when it comes to ensuring that your applications are developed with these in mind. That said, when we develop securely and we implement these practices within our development lifecycle, we're ideally future proofing our applications and ensuring that we're forward thinking in terms of what could go wrong when it comes to poorly coding our applications and preventing vulnerabilities that arise from poor coding. That said, one of the things that we can talk about is shifting left when it comes to secure coding. So, in this phase, we're not only talking about the security team being responsible for ensuring that applications are developed securely, but also assigning some of the tasks to developers, which means by either providing them with training, secure libraries that they can build off as baselines from to ensure that some of these vulnerabilities are mitigated even from the design phase in terms of how they use secure libraries and APIs and other things throughout the development lifecycle. And as a business, what does this mean for us? It means we get a competitive advantage. If our applications have a reputation of being secure from vulnerabilities, it provides us with a market differentiator, especially in the industry where data and security is now paramount. Let's talk about some common vulnerabilities when it comes to secure coding. Buffer overflows is one of the most common vulnerabilities that we see as a result of poor coding. What are buffer overflows? This is when more data is written to a buffer than it can handle, and a lot of times these can arise in from use of non-safe memory libraries. We can talk about uninitialized variables, where variables are used without values, leading to undefined behavior and potential data leaks. We can also talk about improper input validation. This is where inadequate validation or sanitization happens, and therefore client supplied data can lead to vulnerabilities and attacks within your application. And then we can talk about the use of hard-coded credentials and secrets within your applications. These include embedding API keys, cryptographic keys, or service tokens directly in your source code. And then we can talk about race conditions. In race conditions, the outcome of a process is detrimentally affected by the timing or sequence. So, for example, rather than authentication before authorization, we might authorize before authenticating fully, which can lead to an exploitation of the application within question. And then we can talk about error handling issues, where poor error handling can lead to data leaks in the back end, such as stack traces or database dumps and information. And then we can also talk about insecure library and framework use. A lot of times nowadays, we're talking about applications being developed from libraries that are out there, for example, Node.js's, and we can talk about APIs and stuff. And if we don't use libraries that are secure from vulnerabilities, these will tend to show in the larger effort within our applications as vulnerabilities that can pose and threats to the entire applications that we're talking about. So, what are some secure coding methodologies? Obviously, we mentioned secure design principles in the previous slides. One of the things that we need to understand is embedding least privileges, ensuring that we're designing with defense in depth in mind, we're failing securely, and we're doing security by design within our applications. We can talk about risk assessment and management, where we're identifying and evaluating and mitigating these risks early in the development life cycle. And then we can talk about security testing. This should always be part of our development lifecycle where we're regularly testing for our code through static and dynamic analysis and sometimes even penetration testing to evaluate the behavior of our code within the applications that we put out. What are some of the tools and that we can use for to ensure that our code is designed securely? We have static application security testing tools. These are tools that analyze the code for vulnerabilities. And then we have dynamic application vulnerability testing tools. These actually test the applications in real time once we have actually finished coding, and they actually help us identify the behavior of the application in a simulated real world environment. And then we can look at dependency checkers. One of the things that we see today is a heavy dependent on OSS components. We need tools that can analyze and monitor these third-party libraries and look for dependencies with known vulnerabilities to ensure that we can mitigate these vulnerabilities before they become a larger problem within our application. Let's talk about some best practices for secure coding. One of the first things that we can talk about is memory management and the use of memory safe languages. So for example, throughout the development lifecycle, we're selecting programming languages that are designed to handle memory safely and avoid the introduction of buffer overflows within our application and subsequently leading to vulnerabilities within the application. So for example, rather than choosing a language like C, which you need to actually ensure that you're managing memory safely, we can go with more newer languages that that have inbuilt functionality and capabilities to handle these safely. And then we can talk about input validation and sanitization. Anytime our application accepts user data, we need to validate and sanitize that data against what the application expects to ensure that we are not introducing vulnerabilities within the application, such as SQL injections and other command injection type vulnerabilities. We should avoid hard coding credentials and secrets within our applications. These include API keys and tokens and other secrets such as connection strings to data stores and other critical components of our applications that these can provide unwanted access to without the proper channels such as authentication and authorizing before having access to those. And then we can talk about the use of secure libraries and frameworks. A lot of our applications today are designed using libraries and frameworks that are out there. We can either customize these libraries and remove components and elements of it that our applications don't need to ensure that we are using these libraries safely. And then we can handle errors in login to ensure that our applications fail safely. And in terms of login, anytime there's potential misuse of the application, we can go back to logs to ensure that we can do some forensics within that application. And then coding standards. Coding standards is one of the biggest things that we need to enforce throughout our development lifecycle. This includes having like the processes and policies in place to ensure that developers or engineering teams are following certain standards when it comes to developing securely and ensuring that we can provide the training and other resources to developers to help them with that shift left mentality, as I mentioned earlier. And then we can talk about safe serialization and deserialization. This is ideally about how we handle data, how we package and unpackage data within our applications. It is always ideal to ensure that we're doing this safely because these can also tend to be ways that introduce bugs and vulnerabilities within our applications. And then we can talk about protecting shared variables and resources, especially when we're talking about concurrent use within our applications. This include environment variables and other application variables that we call during application runtime. Then we can talk about avoiding direct interaction with the system. A lot of times, certain applications are designed to interact with other systems within our environment. We should always code our application and design our application to avoid these kinds of interaction at a minimalistic approach, so we can avoid any kind of malicious attack or malicious exploit of a vulnerability within our application having a downstream effect on other systems within our environment. The use of checksums and hashes for integrity verification. This can either be when we send out our application code to our end users and so forth. We ensure that we have these in place to ensure that anytime there's some manipulation of our code, end users can verify these applications, and even we can use this as ways to verify our application code against known hashes and checksums. And then lastly, we can talk about code reviews. This is an essential and big part of secure coding, where we have secure coding review sessions where we look at code manually with some help of automation tools and so forth to make sure that any potential introduction of bad code is caught during the development lifecycle and mitigated before this goes into production. All right, in the next part of our video, we're actually going to do a live walkthrough of some code. We're going to look at a simple file upload application. This application accepts images as uploads and saves it to the server. We're going to take a look at the backend code to see if there are any vulnerabilities, and then we're going to fix those vulnerabilities to give you a sense of what some coding best practices look like. Stay tuned when I come back. Hello and welcome back. So let's go ahead and test out our secure coding application just to put into practice all the things that we talked about. As I mentioned, we are going to test this with a simple web application. It's a file upload application that allows you to upload images that get stored in the backend server in an uploads directory. We will take a look at the functionality of application, just see how it works, and then we'll go ahead and look at the backend code just to see what it's doing. At the first glance, the application should work just fine and should be perfectly working fine with no issues. But then when we take a look at the backend code, we'll see a lot of things that are pretty much flaws that we will need to fix as far as like coding is concerned, to kind of demonstrate some of the concepts that we talked about and so forth. So let me open up PyCharm, which has got our code here as usual. This is our index.html page. This is the landing page that we see once we kind of navigate to our applications when we start it up. We have a login failure page. This pretty much handles login failures, assuming that you supply a wrong username and password. This handles all that. And then we have our upload page, which is actually where we navigate to upload our image. And then we have other packages in there for our Node application, like our Node modules. And then we have our server, which is pretty much the core of our application. I'll open up the server code and then we'll kind of run through it quickly. So as usual, we're initiating things here. We're setting up a session. As you can see, we have a secret value and we have something coded in there. It says very secret value. This is like our secret token and so forth to manage sessions. We'll talk about these when we come back. And once we navigate to our home page, we get our index.html page served up to us. The login page handles all our login functionality. And then we have our post method, which essentially posts like the file that we want to upload into our uploads directory, which is essentially an image and so forth. As you can see, we have our credentials in there. For login, it's admin and admin, which we'll be using to log into our application. So this is all set up. The code looks fine. I'm going to close this out and I'm going to open up command prompt. And then we are going to pretty much navigate to our application, which is in our documents folder. And just to see where it is. So we call the secure demo, secure coding demo. That's it. So I'm going to navigate into secure coding demo and let me clear this up. And then what I'll do is initialize this just in case we haven't done this yet or we need to reinitialize it. So I'll do this npm init that that initializes our folder. Our application is good to go. I'll clear that up again, and then what I'll do is actually I'll just leave it up, and then I'll start our server. So node.js, node server.js, and then our server is now running on port 3000. So this is where our application is. So if I navigate to, I'm going to use Firefox this time because we are going to do some packet capture eventually, just to show you a couple of things. I'll do that now. If I navigate to localhost, which is where our application is stored, port 3000, I should get, there you go. And it says, welcome to Secure Coding site. So our application is working. Our simple web application is working. We can see. I'm gonna go back slightly just to give it a folder structure again. As you can see, we have our uploads directory. That's where any upload that we do will go into. So let's test this out. Actually, let's just see if our application works. It should be fairly simple. I'm gonna pull out a couple of things. Remember, we had our credentials in here, and it says our login is admin and our password is admin. So let's go ahead and use that to log in and see if that works. So we got admin, and then we hit login, and it looks like we are logged in. So now we have the ability to upload a file. So I'll do a simple upload, browse, grab like a file. Let's go to something like pictures, camera roll. We'll grab image test, and we'll hit upload, and it says file uploaded successfully, and that's awesome. So this should take us back to our home page, or it takes us back to our upload page in case we wanted to upload another one. Let's just do another one just to have like 2 images. So I'll grab this other one, image test 2. I'll do an upload. Okay, application looks like it's working great. So now everything seems fine. Like this application looks okay. It does what a user expects it to do. We're able to log in. We have our username, password, and now we're able to also upload files, and then it tells us like if it's successful or not and so forth. That's fine. Now I'm gonna do something else. Let me close this out just to test out our login failure page. So I'm gonna open up Firefox again. Not now. Navigate to our application again. Hopefully it's cleared up the cookies. There you go. And then I'm gonna do something like admin, and then I'm just gonna do password just to see if our login failure page works. So if I do login, it should complain. So that page works. Ideally, we're not even worried about this page so much, but just to make our application more user friendly. So let's return to our login page, and if I did admin and admin, that should log in. Perfect. So as you can see, this application works fine. There are no issues and so forth. Now to an end user, this is great. To an end user, non-malicious end user, this is great. Now let's say to a malicious end user who is attempting to exploit some vulnerabilities within our application, we're going to find out, as much as this application seems very simple and straightforward, there are a lot of things that we will need to worry about because of how this application was designed and coded. So I'll come back and we'll walk through the code. We'll take a look at all the flaws that are within this application's code, and then we'll fix them and see if we can do something else with that. Before we look at the code, let me open the application back up, and just to kind of describe the two scenarios I mentioned. So we potentially have an end user who's just enjoying the application. They're uploading images. That's fine with them. And then we have a malicious user who he or she is attempting to exploit vulnerabilities within the application. So what I'm going to do is go back to the application, and I will just simulate or talk about a few things that a potential malicious user could look like or could look for. I mean, I assume I would be looking for potential SQL injection opportunities here, and I'll be trying to figure out ways to exploit the authentication mechanism so I can get within the application without having a username or password. That said, with this particular application, we kind of saw the code initially. We know it's not run, it's not powered by a database in the backend and so forth. We do have credentials that are embedded in there, but a malicious user could potentially just try out usernames and passwords and can potentially guess the username and password because we fairly have a simple username and password which says admin and admin. Now you'd be surprised, there are a lot of applications that have these flaws within them, secrets and credentials and so forth embedded within those applications, and these are like the first avenues for exploitation of these applications. So a potential malicious user could try to exploit this within the application itself. I'm gonna log in just to show you. As we are well aware, this application supports uploading images. A potential malicious user could try to see what else can I upload. Can I upload a virus? Can I upload a malware? And see if that works. So like I could do something like, rather than a image file, I could go to, like, say documents and try to pick some random file. Let me grab something here. Just something downloads. Let me actually just grab I'm gonna grab some random file, installation file, and let's see what happens. And guess what? It actually uploaded it. But this application is supposed to be for images only. So that alone, that's a flaw already that we found within our application. So that said, let me close this out. I'm gonna go into a couple of things actually. Let me go into the folders just to show you that we did successfully upload that installation file, which we shouldn't have been able to, but let me do this. So I'll go in the uploads and you can see that that installation file was indeed uploaded. So for a malicious user, the typical thing would be they upload their malware or reverse shell or anything like that, and then they're able to call it back, and then pretty much your application exploited. They're able to navigate through your system and so forth. So this is a bad design to begin with. It shouldn't allow us to upload anything else other than images. Now let's go and look at the code, and we'll walk through all the vulnerabilities within the code itself. So I'll minimize this, go back to PyCharm, and here we have our code. So over here, we're just initializing node constants and so forth. All of that is fine. There are no issues here. Where we start to have issues is once we start looking at our methods and our functions. Like if you look at this is meant to handle our session, right? This is for our session management. We already have like an embedded secret in there which says very secret value. Now we should never have to write secrets and connection strings and anything that is meant to be hidden within our code. So that's our first flaw right there. We would have to fix that, find a better way of handling sessions. Either we're going to move these things into a config file or environment variable that we read during runtime and store it in memory and then discard it once we're done with it, and to avoid this kind of situation where we're actually embedding secrets within our code. So this is our first flaw right here within this code. Now, as I mentioned, when we were running the application, it seemed all fine, right? Until we popped the hood, and now we're looking under the hood and we're going, oh my God, like this is what it's built like, not very secure. Now, one of the things that we can actually also look at within the code itself is when we come down here, you notice this is another flaw we're doing here, which is we're embedding our login credentials within the code. Now, if any malicious user haven't had access to this, somehow we essentially had the keys to the kingdom within the code and just made their job a lot easier. So we're gonna have to fix this, where we need to either move this also into some configuration files and read that from there as an environment variable during runtime, stored in memory, same thing as our session handling one, and that should at least provide some level of security within that space. That said, one of the biggest flaws that we just seen is our ability to upload any file versus what this application is meant to accept. What is this application meant to accept? We only wanted image files. So in our upload method, as you can see, we're basically just taking any file that the user sends to us and places it in there. Now that has the potential to allow a user to upload malicious files and malware and all of those things that we mentioned. As you saw in the example I did, I ended up uploading like an installation file pretty much. So we're gonna fix these I'll come back with the fixed code, and then we'll walk through kind of the changes that I did, just to kind of at least help us secure this application a little bit more. So stay tuned, and I'll be right back in about 10 seconds. Okay, so now let's look at the fixed and updated code. Before we do, I'm just gonna walk through the old one just briefly, as we kind of already did that. Some of the things that we found out in the old code was that we had secrets that were embedded in code for like our session management. We also noticed that we had our credentials, admin and admin over here, that was embedded in the code as well. And then we also figured out that our upload functionality actually doesn't really care as far as whether it's an image or not. It just grabs whatever the user has supplied it. So these were the three main things that we are fixing, just to give you a reminder of that. Now on the right side, this on the left side is that vulnerable code, or the code or original code with a lot of vulnerabilities in there. And on the right side is our updated code. I'm gonna expand that, and then I'll just walk you through some of the enhancements that we did in this code. So for starters, what we did is we actually introduced a configuration file, which we call the .env. Like I mentioned, it's basically gonna run as an environment variables that we pull into memory when the program starts up. I'll open that up briefly just so you can see what's in there. So now we've moved that secret key into a config file that we read into memory. We've now moved our username and password into something else. And this time I just changed it to your secure password. I can make it like admin again, doesn't matter. But as this is assuming that we're choosing something even stronger and so forth. But we've moved those hard-coded credentials into a configuration file. That's one of the first fixes we did. I'll go back to the server code. And just to remind you, there are a few more modules that I added. So one of them is Helmet, which is a security related library for handling HTTP headers and so forth. And Helmet is basically going to apply some of the security enhancements that we're doing. And then obviously, we also added some session configuration stuff to handle users' cookies and so forth, to ensure that we can manage those sessions securely by setting like HTTP only and so forth. And then lastly, introduce some file handling mechanisms to ensure that what we're going to do is we're going to read the actual file that's uploaded. We're going to check the MIME type, which is basically saying like what kind of a file this is. We're going to read the contents of the file itself, and then if it's not an image, we'll just essentially delete it from the server and display a message that says it's not an image. And this is where we do that. So if you recall, let me actually go back to this. Let me do this one more. So this is, where's my file, single file handling. There you go. So this is where we essentially handle like our upload again, and basically we kind of yeah, this is so this is where we're actually checking all this place all the way up to here is where we're checking the file itself, just to make sure that, you know, it has a MIME type of image and so forth. There's a lot more enhancements we could do, but this is just to kind of like show you at a baseline how we can fix vulnerabilities in code and so forth for an application that seemed pretty much normal, but then actually find out that it's, you know, vulnerable within the code itself when we look at the backend and so forth. So yes, so yeah, this is where we check whether it's an image type. We'll actually read the file itself once we do an upload. We'll check here if it's an image type, and we'll use this to read the file itself to see if it's an actual image. If it's not, we'll just delete it and show that error message and so forth. So yes, so the code is pretty much like fixed in that regard. What I am gonna do is I'm probably gonna run both apps side by side. Let me actually open command prompt. I do need to install some of the libraries that I added, and I'm gonna do this here. So let me go back to command prompt, and now let me open a new one. I'll open a new one. pull that, close that. Let me just do this command. I'll open a new one, and then I'll keep both directories just so you can see. So cd documents, that's where it is, and then dir, and I called it secure coding demo fixed because the old one was called secure coding demo. So now we're gonna navigate into secure coding demo fixed. There you go. And then let's clear this. Let's initialize this as well. So npm init tag y, and that's initialized. And then let me actually install some of the libraries that we added to enhance our code. So we added .env. .env actually is the library that we're going to use to determine some of the environment variables that we're adding into our config file and so forth to be able to call them. And helmet, as I mentioned, gives us the opportunity to do this security enhancements, and file type is what we're going to ensure that we're using to check our MIME type for images and so forth. So let me install those. That should take just a second. We are good. I'll click. So now let's log into our fixed version, and we call it admin. And let me see what I got for the password there. What's going on here? Let's go back there. Let's see what we chose as a password. Your super secret password, something like that. Your secure password. Obviously this isn't a secure password, but what I'm trying to demo here is not about passwords. We're just basically trying to demo the fact that these shouldn't be embedded in code. As we can see in our old code, we did have that admin and admin embedded in there. So we're moving these to configuration files. The goal is to avoid common coding mistakes and things like that. So let me paste that here, log in, and we don't want to save that. Let's just, now we're in our application. Great, right? So notice that when we came here in the old vulnerable one, we actually uploaded an installation file and it worked. This shouldn't happen in the second one. That said, let's go ahead and check it out. So I'm gonna do like the normal upload. I'm gonna go to pictures, pick image, and do. So let's hit upload and see what happens. Once we hit upload, that looks like it uploaded. I'm not sure why it's delaying. It should have given us that success message, but we can check it to see if it's in there. So let's go. This is the old app, secure app demo. We're in the uploads. You can see all the files, including the installation files that we had, which shouldn't be in there. And now let's look at the fixed code. When I go here, we can see in uploads that image test is there. Now let's see if I try to upload a source file or some installation file, which in this case we assume would be like our malicious file that a malicious user will upload. So let me just go back there to browse, and then I'm gonna try to grab like installation file, like, and let's see what happens. And look at that, it tells us that only images are allowed. So all our fixes in the code are working. I hope you enjoyed this. Just to give an idea, recap. So we had a simple file upload application. This is the original one we built on the left. It's meant to allow all the images to be uploaded, but somehow we were able to upload malicious files such as installation files or any other file. We also had some code embedded in secrets. We had some secrets embedded in code, such as our usernames and passwords. We had some session management tokens embedded in the code as well. What we did in the fixed version was we introduced a environment and config file, and basically moved everything that as far as configurations are concerned. And what we're doing here is referencing the environment variables to call these credentials when we run this application versus actually embedding them in the code. So this was just to give you an idea of what it means. An application could look just fine at the front, but when you look in the back end, behind the hood or under the hood, there's a lot of things that could be happening, such as bad coding, secrets embedded in code, and so forth. And malicious users can exploit those vulnerabilities. They can look at those gaps and use them as entry points into exploiting your application. So thanks for joining me as always. I hope you enjoyed this secure coding session, and I'll catch you guys next time.